Hey guys, so welcome to a brand new unit. This is chapter 5. The title of 5.1 is called Composite Functions, okay? So first thing we're going to do is we will read the box. Here we go. Whoop. Okay. Composite function. Given two functions called f and g, the composite function denoted by f, and then this is a little bubble g. It's different from f solid circle g, because if it's f solid circle g, that's multiplication. But this is f bubble g. It is read as f composed with g. Okay. Or in class, I will also read this as f of g. Okay, so aka, let's spell this out, aka f of g. Okay, most likely you're going to hear this right here from me. It's denoted by, or is defined by, f bubble g parentheses of x. Please don't say this is multiplication. The parentheses in here is no longer multiplication, but this is read again, f of g of x. Okay, which is equal, sorry, this looks like a minus sign, but this is an equal one. Okay, equals to, so this is f bubble g of x. So we can read this multiple ways. F composed with g, so f composed with g of x. And that is exactly the same as f parentheses, g parentheses, and then close the two sets of parentheses. And again, these are both the same thing. It is read f of g of x or f composed with g of x. Okay. The domain of the composition function is the set of all numbers. Okay, set of all numbers in the domain of g. Okay, such that g of x is in the domain of f. Okay, so what does that really mean? So let's say I have g of x equals 1x. I'm sorry, not 1x, 1 over x. Would you agree that this right here, the domain of g of x is x can never ever be 0? Okay. Now I'm going to give you f of x. F of x, let's make up a function. F of x is, let's say, x squared. Okay. All right. So would you agree separately, this domain right here, x can never ever be 0. This domain right here, it's all real numbers. Okay. So when I compose them, f composed with g. In this case, our inputs are x. So we're going to say of x, which is equivalent to f of g of x, f of g of x, okay? And which is, okay? Now notice how your input is now g of x. So now we're going to go, hey, f of g of x, g of x is 1 over x, 1 over x. That's what I'm doing. My input, my new input of f is now the entire g of x. So the entire g of x is 1 over x. So right away, remember, g of x can never, ever, ever be 0. So when I compose them, okay, so now here's my new input. No longer just x, but my new input is 1 over x. So now I'm going to go, hey, every time I see an x, I'm going to put in 1 over x. And then this is x squared. So now I want to write f composed with g of x. Sorry, this is an f, okay? F is 1 square is 1. Okay. X square is x squared. This is my answer. And the domain is because I have to take into account of the inner component. Okay, this is the inner component here. So the domain of the entire function, it's x can never ever be 0 too. Because the inner component, we need to take that into account as well. Okay, so let me zoom out and then let's talk about the domain again. The domain f composed with g is the set of all numbers in the domain of g. And that is true. Okay, so here's the domain of the composite. And it says this is the domain of the function g. such that g of x is in the domain of f. So now that is also included in the domain. Okay. Example 1. Evaluate 1i, 2i's, 3i's, and 4i's. Okay. For each problem, we have to answer 4i's. Let's do 1i first. You know, I'm gonna need to get a pencil. Just I make a lot of mistakes, and a pencil and an eraser would be good, right? 1i says, okay. 1i said, I would like for you to do a composition g of f of 2. Okay. By definition, this is the same as g of f of 2. So what you would need to do first is the inner component first. Okay. What you need to do is find f of 2 first. Well, you have two awesome functions here. Here's the f function, a set of ordered pairs. Here's a g function, another set of ordered pairs. So first thing is, let's try first. First thing is you need to find f of 2. Well, here's the f of function. F, this is negative 2, negative 1, 0, 1. When the input is 2, the output is negative 3. Okay. Then, second piece is that, hey, f of 2 is negative 3. You're now going to do g of negative 3. So the output of this is now the input of this. See this right here? This output is now in here. So now we're going to look at g function. When x is negative 3, the output is 1. So my answer is g composed with f of 2, or g of f of 2, all of that comes out to be 1. This is the final answer. Okay, so this right here is what I want to box. Whoop, whoop, whoop. There. Okay. You can also write this as an ordered pair. The initial input was 2. The last output is 1. Okay. All right. 2i's. Now I'm asking you to do f composed with g of 0. F composed with g of 0. This is the same as saying f of g of 0. Okay, which, let's box this up. Let's see what our final answer is going to be. First, you would need to do the inner component, g of 0. So now, which functions should we focus on? The f function or the g function for step 1? You would need to focus on the g function because it said so. When the input is 0, not 0, not 0, okay, here's 0. When the input is 0, output is 2. Then the second step, we are done with this. So take whatever you have, okay? So now we're going to go, hey, f of 2. This answer goes here. Now we need to focus on the f function. Not 2, not 2, not 2, not 2. Here's 2. F of 2 is negative 3. So my last output is what the composition is supposed to be. Okay? So that's what we have. Or we can write that as an ordered pair. The very, very first input, which is 0. Very, very last output, which is negative 3. 3i's, we have f composed with f of negative 1. So f composed with f of negative 1, or f of negative 1 equals, let's box this up. Okay, so the first thing we are going to do is the inner component, which is f of negative 1. Well, here's f. That's not negative 1. Oh, there it is. When the input is negative 1, the output is 1. Then the second piece, okay, looks like I'm using f function again. So f of, now this is going to be in here. F of positive 1. Not positive 1, not positive 1, not positive 1. There's positive 1. When the input is positive 1, the output is negative 1. So this is where my answer is. This whole thing goes right here. Okay? So, or we can write this as the very, very, very first input and the very, very, very last output. Now, last one, 4i's. 4i says, I would like for you to do g composed with g of -3. So g composed with g of -3, which is equivalent to g parentheses g, so g of -3. Let's box this up. Okay. All right, so first step, we are going to find the inner component, g of -3. So let's look at g function, -3. When g is -3, here's -3, yay! The output is +1, okay? Second step, now that we know what this is, we can substitute that for +1, okay? So let's go find the g function when the input is -1. Not -1, not -1, not -1, not -1. What? It doesn't have. I mean, not, what am I saying? I don't want a negative one, I want +1. Not +1, not +1, not +1, not +1, and definitely not +1. So notice how in the g function, I don't have an input of a +1. Well, if I don't have an input of +1, the output doesn't exist. Does not exist. Okay? So can I spell D-N-E? D-N-E spells does not exist, right? So does not exist. Voila. Okay? That's how we do that one. Not so bad, right? Okay. So now the next thing we're going to try to do is, what if I give you an f function that's a graph format and a g function that's also a graph format, all right? Let's turn the page. Here we go. Not turn the page, but I'm sorry, go sideways. Whoop, whoop, whoop. Okay. Looks like I might not have enough space because I wrote all over this stuff. If you have space, then go ahead and do it right there. If you don't have space, then I'm just going to do it right above it, right here. Okay? Here we go. 1i. 1i says g composed with f of -2. So g composed with f of -2, which is equivalent to g of f of -2. Okay, let's box our answer. Okay, so the first piece we are going to try to do is do f of -2. F of -2. G of f of -2. We want to do the inner component first, just like PEM does, okay? The parentheses first. So f of -2, let's go look at which one is the f function. If you don't have printed notes, I'm just going to zoom in really quickly, okay? Whoop, there you go. Which one's the f function? The lighter one or the darker one based on my black and white printed copy here? Yeah, this darker one, right? And it says, I need to find f of -2. Does this darker function, which is the f function, has an input of -2? Is there anything over here from this f function? No, there's nothing here, guys. There's nothing over here. So, because there's nothing on that side, which I'm going to move right here, it doesn't even exist. Does not exist. So guess what? My answer is does not exist. That is just that easy. Because it wasn't, the inner component doesn't exist, the entire composition doesn't exist. Okay? All right, 2i's. 2i's wanted us to do f composed with g of 0. So f composed with g of 0. So by definition, it's f of g of 0. Let's box this up. Wouldn't it be cool if we have a DNE again? Does not exist. Okay. So the first thing we are going to try to find is the inner component, which is g of 0. Let's go check it out. Okay. So here's the lighter one. When x is 0, which is the input, looks like y has an output at a +1. Okay. So in the second step, because we know g of 0, it's +1, we will now substitute that with +1. So now we need to go focus on f. So f is this darker function. When the input is 1, the output looks like it's about It's about what? -1? Okay. So what do you think I need to write in here in my final answer? The final answer is -1. Okay. All right. So we have 2 more letters left. We have letter 3 I's and letter 4 I's. Okay. I'm just going to do 3 I's and then I'm just going to let you do 4 I's on your own. So here we go. 3 I's. I'm kind of running out of space, so I'm trying my best to find all of the room so I can write my work here. 3 I's want us to compose f with f, right? Of -1. So f compose with f of -1, which is equivalent to f of -1, okay? Which, let's box this up right here, okay? Actually, do I need that much space in the bottom? Looks like, okay. Well, I'm just worried that I might not have enough room to finish 4 I's, or just to give you the answer for 4 I's, okay? Okay, so first, we are going to try the inner component, which is f of -1. F of -1, again, I'm going to focus on this, okay? Wait, what? There's no -1 input? Wow, that is awesome. Does not exist, right? So that is my final answer. Woo-hoo. All right. I would like for you to accomplish 4 I's right here for me, okay? On your own. Do this without me. So, on your own. Please don't write on your own, okay? Actually do it. Box your final answer. It'd be awesome. All right. Now, and do it right now so you don't forget. Then we are going to try to move to example 2. Okay. Zoom in really quickly. Here we go. Example 2. Instead of giving you set of ordered pairs or 2 graphs, I'm actually now giving you functions or equations. They're all functions, but now equations, okay? So we have A, B, C, D, just like 1i, 2i, 3i's, 4i's. Now we just have A, B, C, D. Okay. So for part A, it wants us to do f of g of 1. So f of g of 1, which is equivalent to writing it this way. Let's box our answer. All right. First step, we are going to do the inner component, g of 1. So we're going to have 4 times 1 to the third plus 1. 1 to the third is 1. 1 times 4 is 4. 4 plus 1 is 5. Second step, okay. Now that I know that g of 1 is 5, we are now going to substitute f of 5 equals, that has to be plug in into the f function. So 2 times 5 squared, because this is x squared, plus 3 equals 5 squared is 25. 25 times 2, that's going to be 50. 50 plus 3 is 53. So which number am I going to write in my final answer? You're right, it has to be the last output, okay? So this is your 53. Okay. I would be going to be if this is not, you know, if we just didn't finish a test, so this is where I'm going to stop. But before I stop, I'm going to give you a joke. Why are A's like flowers? Why are letter A's like flowers? Because B's come after them. Get it? After letter A, letter B. So, B's come after A's. Anyway, have a wonderful day. I'll see you guys next time.